In the last video, we just kind of briefly looked at how you would write an equation for a line. Um, that was a very special case where they just happened to give you the y-intercept. A lot of times you don't necessarily know that y-intercept of the line. They might just randomly give you 2 points on the line, and neither one of them being the y-intercept. In which case, we're going to need a way to write a linear equation if we're given, other bits of information. So what I'm saying is, if I told you that a line had a slope of 3/4 and a y-intercept of -7, it's not that difficult to write the equation of the line in slope-intercept form. Literally, you just put in the slope 3/4 for m, so 3/4 x, and you put in -7 for b, and that's all it takes. I mean, that's pretty darn easy. Well, the problem is it's not always given this way. Sometimes they'll give you the slope and they'll give you something other than the y-intercept. Like maybe the line passes through -3, 7, for example. Well, -3, 7, that's not a y-intercept. So it's not going to be so easy to fill this number in. You still know the slope is 3/4. Or maybe they don't even tell you the slope and they just tell you 2 points the line passes through. Because all you need are 2 points to make a line. So if they just give you these 2 random points and say, okay, what's the equation of that line? Where neither one of these is the y-intercept. What do you do then? Well, it's a little bit more difficult. Now, like I said, if they just give you the slope and they give you the y-intercept, well, life is very easy. You just fill those in. But what we need is another form for all the other cases when they don't tell us this information. They tell us other things. Right? And what we're going to use, what's wisest to use, is what we call point-slope form. Point-slope form is not the most pleasant thing to look at, but it's a great way to easily write an equation for a line. So anytime you're told to write an equation for a line, unless you're just told here's the slope and here's the y-intercept, you'll want to go through what's called point-slope form. Right? So unlike slope-intercept, it's not just solve for y. Point-slope form looks like this. It's y minus y1 equals m, once again slope, x minus x1. Now, as far as what these variables are representing, the x and the y, those are the same x and y that show up in your slope-intercept form or your standard form. It's just plain old x, plain old y. You don't put any numbers in for those. Now, all the other letters here, first of all, m is still representing your slope. That's how steep the line is. So that's why we keep that letter m there. Right? Now, this x1 and y1 together make up 1 point on the line. They give you a random point that's on the line, not necessarily a y-intercept. Even if it is a y-intercept, it would still work using this. So some random point, -3, 2, is a point on this line that I'm thinking of. And they tell you the slope. Well, with this point and slope, you can write your equation in this form. And then you could, if you wanted to, solve for the y variable and put it in what's called slope-intercept form. So this will at least get you over the hurdle of writing the equation of line. As an example, they might say, write the equation of line. The equation of the line. That passes through. Let's just make up a point. Let's say -6, 4. And has a slope of -1/3. So they want you to write the equation of a line that passes through this point. So this is a point on the line, and this is that line's slope. So there's only one line in existence that passes through this point and has this as its slope. They're asking you to actually find the equation of that line. Now, graphing this is not difficult. Very easily we could graph this. How? Well, it passes through that point. So guaranteed, -6, 4. It passes through this point in quadrant 2, and I know how steep it is. -1/3. Now, we, again, can consider that -1 over +3, which means we're going to go down 1, right 3, down 1, right 3, if I could keep track here. 1, 2, I'm trying to line this up, 3. Okay, 1, 2, 3, there we go, not too bad. Or I could think of it as up 1 and then left 3. It's not going to be the same point as what I just plotted, but it will be another point on the line. So I really should put slashes, but you get the idea. Graphing this line is not difficult. It's not like that's one big mystery. But writing the equation for it, well, yeah, that's not such an easy task. But actually, it's not bad as long as you understand we use this form for writing equations. So anytime they say write an equation, you should immediately think point-slope form every single time. Right? So graphing wasn't the issue. It's what does this equation look like? Right? Well, as long as you have the two qualifiers, do you have a point the line passes through? Sure do, -6, 4. Do you have the slope of the line? Absolutely I do. Well, then you're in business. It's very easy. This right here represents your x1, -6. This right here is your y1. It's your x and y coordinate of the point of that line. And this is your m, of course. So you put those pieces together in this point-slope form. So point slope says y minus y1 equals m times the quantity x minus x1. So y minus the y coordinate, which is 4, equals -1/3 x minus the x coordinate. Now it does go a -6. So we would simplify that ever so slightly, and we would say, okay, I guess my answer is y minus 4 equals -1/3 times the quantity x plus 6. And that could be a legitimate answer. However, this is an answer that would be considered in point-slope form. 9 times out of 10, though, when they want you to write an equation of a line, they want it back in that slope-intercept form. You say, so what do I do now? How do you put a line in slope-intercept form? You solve for the y variable. So we're going to solve for the y variable here by first distributing the -1/3. So let's write y minus 4 equals -1/3 x. That will be -2, -1/3 times 6. And then add 4 to both sides, and what you get is you get your slope-intercept form. -1/3 x plus 2. Slope-intercept form. So what do I know about this line that I didn't know from the start? Clearly, the y-intercept was at 0, 2. So if I were to graph it, it would pass right through the y-axis at 0, 2. But the idea is this is what's called slope-intercept. So even though they may say, write the slope-intercept form of the line with these qualifications, don't think, okay, immediately I have to go to this. No, that's going to be your final task, is put your line in the slope-intercept form after you go through point-slope form. Anytime I hear write the equation, this is what I'm using every single time. Write the equation of a line, use your point-slope form. That's how you're going to write your equation. And once you write your equation, which is what we did, okay, now put it in the form they asked. They want slope-intercept? Okay, we'll put it in slope-intercept by solving for the y variable. That's usually the process that we have to, go through. Right? So the idea here is they're going to give you certain scenarios. Now, it's not always so nice like this one where, okay, here's a point the line passes through, here's your slope. I mean, many times it is, but sometimes they give you other types of scenarios, and that's really what we need to look at. Okay, so let's kind of do several scenarios that you could run into. Situations that do pop up. So let's make general directions here. Say, right, We'll say the slope-intercept form. Intercept form for each line with the given conditions. Okay, now again, they say write the slope-intercept form. But again, what they're saying, yeah, eventually they want their final answer in slope-intercept form. So we have to go through this point-slope form as this word write. Anytime they say write the equation of the line, I don't care what form it's in, I'm going to point-slope to get the equation written down first. Once it's written down, then we can go to that slope-intercept form. All right, so we'll kind of do several examples here. We'll finish it up in the next video. But let's go with the first one. First one, we'll just say passes through. Just do one like we did before. Passes through -4, -7. Slope is -3/4. There's only one line that has these qualifications. Give me the equation of the line in slope-intercept form. Okay, so job one, we're going to point slope. Whoops, point slope. That would be y minus y1, so -7, equals m, -3/4 x minus x1. Okay, let's make those plus. That's -3/4 x plus 4. We'll distribute. This is point slope form. Now we're going to slope intercept. Sorry. We'll distribute. We get, don't want to write that. Y plus 7 equals -3/4 x minus 3 when you distribute. Subtract 7 from both sides. And what you got is your slope intercept form. Right? Tailor-made for these types of problems where they give you a point and a slope, hence, your point slope form. We'll see many other examples in that last video here.